Yes, in this video we are going to start the new concept that effect of reheat in multi-stage turbine, or prove that reheat factor is always greater than 1. So as we did in compressor, it is similar to that compressor only. So here we are going to uh, prove that reheat factor is always greater than 1, or effect of reheat in a multi-stage turbines. So already you know that what is the meaning of multi-stage. The multi-stage is nothing but the turbine is having more than one stage, or in one stage we are going to divide it into divided it into number of stages, that we call it as a multi-stage. So similarly in the compressor also, it is having number of stages in the compression process. So that is called as a multi-stage compressor. So here effect of reheat in a multi-stage turbine, prove that reheat factor is always greater than 1. So for that we have to consider the temperature versus entropy diagram. So that is given here. This is the temperature versus entropy. Okay, thus in multi-stage turbine, for the same efficiency, each succeeding stage is suffered by the inefficiency of preceding stages, which is handling the fluid at a higher temperature. So as of in case of compressor, here also in the turbine also, so each stage efficiency is depends upon the succeeding stage of, okay, succeeding stage efficiency. If it will give a good efficiency, then automatically what happens, next stage is also going to give the good efficiency. So the entrance of the fluid is fluid entrance at each stage is very important here. So in multi-stage turbine, so for each turbine efficiency is depends upon the succeeding stage of efficiency. Okay, so uh, how it depends, it depends on that succeeding stage is mainly due to the entry of the fluid, or to the next stage, or exit of the before stage before stage turbine. Okay, so now let us consider here the temperature versus entropy type. So here again we are having that P1 pressure P1 to pressure P4. In between these two pressures we are having two stages, that first stage is maintained at a pressure P2 and second stage is maintained at a pressure P3. Okay, so this is a what the temperature versus entropy diagram show. Okay, so here stage 1, stage 2 and stage 3. So this is a turbine three stage turbine. Here it is a initial pressure P1, and this second stage pressure is P2, and sorry, first stage pressure is P2 and second stage pressure is P3, and this is the third stage. Okay, so 1 to 1 2 2 2 to 3 and 3 to 4, these are the stages of turbines. Okay, so and also it shows that this whatever this line is there, it shows the isentropic work done. Isentropic work done. What is the meaning of isentropic? Entropy remains constant here. Entropy remains constant here. So say isentropic work done for the second stage, isentropic work done for the third stage, and this is the actual work done. This line will shows the actual work done, that is from the P1 to P4. Okay, and this is the total isentropic work done. Total isentropic work done. This is the total isentropic work done. Okay, and from this point to this point, it is a actual work done. Actual work done, and this delta ws1, delta ws2, delta ws3 is a stage work done. Isentropic stage work done. Isentropic stage work done. Okay, so this is about the temperature versus entropy diagram. So here how many stages we are taken? We are taken the three stages. Okay, this 1 to 2 is one stage, 2 to 3 is another stage, and 3 to 4 is the third stage of the turbine. Okay, so next here. So here the three-stage turbine is considered between the inlet pressure P1 and the delivery pressure P4. Okay, assume that stage pressure ratio for all stages same, so that each stage in the turbine will have the same pressure ratio. So that P1 by P2 is equal to P2 by P3 is equal to P3 by P4. The pressure ratio between each stage is same. Okay, so that it is a consideration, our considerations. So we are having a three-stage turbine. So in between the inlet pressure P1 and P4 or delivery pressure P4 in the turbine, and also we assume that stage pressure ratio for all stages is same, so that P1 by P2 is equal to P2 by P3 is equal to P3 by P4, and also we assume that the stage efficiency for all the stages are same, and also we assume that stage efficiency for all the stages are same, that is eta s1 is equal to eta s2 is equal to eta s3 is equal to eta s. So this is a stage efficiency, stage 1, stage 2 and stage 3 efficiency, and this is the overall isentropic efficiency, overall efficiency, sorry, it is not isentropic, overall efficiency, that is eta s. Okay, so now let 1 4 double dot and 1 4 are the total isentropic and actual compression process respectively. Okay, so now neta naught is the overall efficiency, neta naught is the overall efficiency. So WA plus and WS are the total actual, this is the total actual, and WS is the total isentropic work absorbed, isentropic work absorbed. Okay, so this eta naught is equal to WA by WS. So that WA is equal to what? Eta naught WS, this is equation number 1. So from this you can get that WA is equal to eta naught into WS. That is equation number 1. So for stage 1, stage efficiency is eta s is equal to WA1 by WS1. So WA1 is equal to what? Eta s into WS1. Similarly, for stage 2, we can write that WA2 is equal to eta s WS2, and for stage 3, WA3 is equal to eta s WS, eta s WS3. Okay, so next, so we can write that the total work is equal to what? WA1 plus WA2 plus WA3. WA1 plus WA2 plus WA3. Okay, WA1, WA2 plus WA3. So substitute all that values, WA1, WA2, W3. So this is a common term, eta is this, take it outside, and here WS1, WS2, WS2. Next, WA is equal to eta s summation of I is equal to 0 to I is equal to K. So that WS1, WS2, WS3 can be written as WSI, where I is equal to what? 0 to K. This is the equation number 2. So now from equation number 1 and 2, equating those two equations, we get that eta naught WS is equal to what? This eta s summation of I is equal to 0 to I is equal to K into WS. So from these equations you can get that overall efficiency of the turbine, that is eta naught is equal to what? Stage efficiency. Okay, that is stage efficiency into summation of I is equal to 0 to K delta SI divided by WS, that is WS is nothing but stage work, total stage isentropic stage work. Okay, as the constant pressure lines are diverging in nature toward the right hand side of the temperature entropy diagram, the isentropic work per stage increases. The isentropic work per stage increases as temperature differences decreases for the same pressure ratio stage efficiency. Therefore, we can write that summation of I is equal to 0 to K into WS1 by WS is greater than 1, which is called as a reheat factor. which is called as a reheat factor. That, or you can write that eta naught is equal to what? Eta s into reheat factor, which is equal to, where eta naught is equal to reheat factor into eta s, reheat factor into eta s. So this is having the same simplification as we did it in compressors. Okay, so there also we have taken three stages. Here also we have taken three stages of turbine. So in the compressor, what happens? The fluid is get compressed, the pressure is increases. So in the turbine, what happens? The fluid will get expand, and the pressure is going to be reduced. Okay, so this is the difference between these two. So in the compressor, we are having that C here. W as by summation of I is equal to K. Where I is 0 to K, delta S1 is less than 1. Less than 1. So it is called as a preheat factor. This is called as a preheat factor. Okay, it is less than 1 in the compressor. Whereas in turbines, we are having that the summation I is equal to 0 to K WS5 is greater than 1, which is called as a reheat factor. That is a preheat factor, and it is a reheat factor. Okay, so this is about the efficiency, that is stage efficiency, multi-stage turbine. In the multi-stage turbine, or we can prove that reheat factor is always greater than 1. Okay, so in the compressor it is less than 1, and here in the turbine it is greater than 1. Why it is so? In the compressor, what happens? The pressure is increases from P1 to P4. So in this, pressure is reduces from P1 to P4. So this is about the turbines. Okay.